Hi, this is Claire Hess,
Lindsay Hill.
And Abby Smith.
and we're here to tell you today about energy in a circuit. How about in our first one that we're going to talk about is a series circuit. Lindsay, how about you tell us about a series circuit?
Alright, so the current, since there is only one path for the electrons, the current is equal throughout. As our example shows, the current is always 2 amps. And for voltage, since there are multiple resistors, the voltage is distributed between them, so you have to add the individual voltages to get the total voltage.
Right, and since the individual voltages are 4, 6, and 8 in our example, you would add them up to get 18 for the total voltage in our example circuit. And then for the resistance, you would use the equation voltage equals current times the resistance, I being the current, and to get that, the resistances would be 2, 3, and 4 in our example, and to get the total current or total resistance in the series circuit, you would just add them together. So our total resistance would be 9 ohms. And then our other type of circuit is a parallel circuit. So Abby, how about you tell us about that?
Well, since there are multiple paths, the electrons are split between the resistors, so you have to add them together for the total. And because the electron only goes to one resistor, the voltage is the same throughout, as you can see in this example.
Right, and then the resistance is a little bit trickier in a parallel circuit, and you have to add or do the inverse of the addition of the reciprocals. So you would do, since the resistances are 1/2, 1/3, and 1/4, you would take the reciprocals of that, 2, 3, and 4, to get 9, and then do the inverse of that, which would be 1/9. And then for the energy in a circuit, or the energy used in a circuit, you would do the power times the time that you used it, and the power is the current times the voltage of the system. And since like in ours, the power of each individual resistor would be 8, 16, or 8, 12, and 16. And then you multiply that by however long you used to get however many kilowatt hours is how the energy would be counted for the bill.
Since you pay for how much energy you use, you want to use the least amount of energy, right?
Yeah, so you could either decrease the power that you used or the time that you use them. So use bulb that uses less watts, such as a compact fluorescent bulb, or you can just turn off the light and use it for a less amount of time.
Yeah, and you can also do this by having high efficiency devices, or devices that put the most power to work and don't lose energy through heat or heating the wrong thing like the air or glass.
Yeah, and you can calculate the efficiency of your appliances by doing the energy that you used in it divided by the total energy that you used. So in our example, if you used 500 kilowatt hours of energy, but you put in 700 kilowatt hours of energy, your efficiency would only be 71%, which isn't that great. So you'd want an appliance that increases that. And then you can also find the amount of energy that you used using the first law of thermodynamics. And Abby, how about you tell us about that?
In a perfect system, energy is neither created or destroyed, as shown by the equation change in energy equals 0. And since energy can be calculated by the change in heat equation, mc delta T, m being mass, c being specific heat, and delta T being the change in temperature, you can add the two changes in heat and it will equal 0.
When you derive this equation, you find that the negative heat loss is equal to the heat gained by the other object.
Yeah, and you can do this with water. You can test the different ways of heating water. So you can test an immersion heater, a microwave, and a hot plate like we did in class. And you can check how much energy you use to heat up each thing of water and check the efficiency of each to decide which is the best way to use it. And I think that's all we have for tonight. And signing off, this is Claire Hess,
Lindsay Hill,
And Abby Smith.